We worked hard to create a culture and a mindset that all of our roles were to serve that operator. Now, if they had dialed down the feeds and speeds, that's a different story. But if there was something preventing him from being, or her from being able to do their job, we let them down. The thing about these complex operations, it's all people. And when people are working together, it's magic.
Most robotics demos never ship. Deployed is about the ones that do. This is Deployed, where physical AI gets real. I'm incredibly excited for this conversation with Pat Shanahan. Pat, been a friend and mentor, but I mean, just an incredible career. 30 years at Boeing on what I think of as the most exciting, the B-2 bomber, the V-22 Osprey, the F-35, the 787, and then went to Department of Defense to help Mattis as Deputy Secretary of Defense, and then as Acting Secretary of Defense, and then a short stint after that helping me and the team at Scale AI. So we'll talk a little bit about what caused you to kind of make a foray into AI for a little while. And then CEO of Spirit AeroSystems. I know other folks at Boeing, you're a legend, and really for your ability to take a program that isn't where it needs to be and get it there. And so I don't think there's anyone better we could be talking with about what it takes to get real complicated systems working.
Hey, maybe before we start,
yeah,
congratulations on building a remarkable company.
Oh, thank you.
It's just so much fun to kind of cheer from the sidelines and to see what you've been able to accomplish. I've been fortunate to work with great people and be a part of great teams. So your introduction was wonderful. My mom is smiling when she listens to this podcast.
Yeah, we're fortunate. We're sitting here in Cobot's Robot Operations Center. There are robots running around behind us. So context, we met in maybe 2018, 2019 when I was leading robotics at Amazon. Jeff Wilkie introduced us, and you came and were just curious about Amazon systems and curious to learn more. And I think we just found we were kind of compatible engineering minds and leaders, and hit it off since then, and have stayed in touch. But I actually don't fully know the backstory. Like, how did you get into aerospace? Like, were you super interested in things that fly as a kid, or what was the path?
It's kind of an interesting story in the sense of, and I'll make it really brief, I was a mechanical engineer at the University of Washington, third generation graduate, and I'd never traveled any place outside of Washington State, really. So I bought a one-way ticket around the world just so that I could see what other places looked like. And over the course of that time, I realized what I wanted to do is work in aerospace and build something that was much bigger than just myself or a small team, something that really would move the industry. And at the time, Boeing was working on these top secret projects, and I signed up to do that, and we never could talk about it until now, but I was working on the B-2 bomber as a fuel systems engineer.
So you kind of like pushed yourself into that overview effect, traveling the world, like how do we...
I didn't know what I wanted to do. I think at that time, and this is, God, it's kind of crazy. It was, should you go work at Microsoft, which maybe I should have done.
That would have been a good gig too.
It would have been a good gig. When I think back of all the things that I've been able to work on in aerospace and defense and the contributions, to society, I'm pretty happy with my choice.
No, I think it's obviously you built an incredible career, and in 2019 elected the National Academy of Engineering for all of that work. In doing some of the research, you've pushed programs to adopt technology earlier and faster to try to move the production ahead. And then, we worked together at Scale AI. From your perspective, like, I knew I was trying to convince you to join Scale AI, and Alex was as well, because we knew in trying to sell the government that we wanted some help. But also I knew that, like, from hey, this company has massive potential, but we need to bridge from where we're at today to something much bigger. And obviously you've done that over and over again in your career. So tell me a little bit, like, how, from your side, when I called you up and said, hey, I'm working for this AI startup, like, what piqued your interest?
Well, my first exposure was Project Maven in the Department of Defense. So just kind of think about where the Department of Defense is today, with AI. Well, when I started in the Department of Defense, there were 12 people working on Maven. And
That's like the sum total of who's working on AI.
that was it. And it was a little carve out.
Yeah.
And it had to be protected.
Yeah.
And at the time, it was.
And that's like 5-6 years ago. That's not that long ago.
2017.
Okay. 9 years ago. Yeah.
You know, it was not only just AI, we were bringing on the cloud. We didn't have the cloud. We didn't have AI.
Right.
But you could see how transformational that capability is, and the potential when it's married up with whether you want to talk about business processes, military operations, medical, the capability that it unlocks to be able to solve problems, streamline workflows, do something, fundamentally different in the physical world. It was lights on for me. This is a kind of a rebirth of a career. Here's the next chapter. Because what you see, having done things for 30 or 40 years the hard way, when something comes along that shows the potential to make things so much easier. I think about, there's lots of talk about AI replacing people. I see AI as liberating people in the jobs they have to do where they're the human middleware.
Yeah.
So I got on this first exposure to the DoD, then working with you and Alex. I've had a number of other experiences along the way, and I feel as though I wish I could go back 20 years in my career with this technology, because we'd make a huge impact, and I think that's what we're going to see in the next 10 years.
No doubt. I mean, just the idea that software becomes increasingly easier to define, right? That we can conceive of how we want it to work, describe it, and have it work, right?
There were all these problems that we couldn't fix because it costs too much. The software development cost was too great. The complexity was too great, the risk. Now, and I'm exaggerating, I could refactor those systems myself.
Right.
Talking to the computer.
Right.
I mean, all this stuff, it gets cleaned up, and the pain of living in that real world goes away. We're more productive. We like our jobs better. I mean, at the end, the productivity comes and the quality comes, but people like their jobs better.
I was reading that one of the programs you worked on was one of the first ones where the whole plane was designed digitally. What were the challenges in bridging that to real production? Because it wasn't done that way before, right?
Yeah, I think you're talking about the 777, and I think it fits in with this overall theme that you have about deployment. So what is deployment like at scale? And for Boeing, and I was probably in my early 30s at that time, the company said, we're going to bet the company and deploy computer-aided design. Computer-aided design wasn't anything new, but it was for the entire airplane. And there were all these people that had done certain parts of the design in the past on a drafting board, or they had used, ceramic models to determine how to make tools and everything. They said, we're gonna burn the boats. We're all in. And so as a young person in that system, hearing management saying we're headed in this direction, and we're betting the company, which to me was, you're betting my job.
Right.
And then there were all the people in the system who were saying it's not going to work.
Right.
This will never work. It never works.
And they all felt like management was betting their job.
Well, they felt that management might be able to have an out, but we were all at risk. And the beauty there was that the management was inspiring us as we went along, that this was going to work. It was going to change the company forever. And all of us played a role. But I think this is what you learn in the real world. There's some people that just never come along until it's actually been proven to them that it works. And I had a job where the first part, major assembly coming from outside of Boeing, was being assembled to a major component inside of Boeing. So the leading edge, which was assembled in Philadelphia, the Ridley Park plant, was being mated up with the front spar. And I remember my boss, Ray Money, said, oh, we've got this important meeting right now. Why don't you go out and figure out, how to get that all loaded and put together? And mind you, this was the kind of first major assembly, so there's probably 100 people standing around. He didn't want anything to do with it if something went wrong. And we uncrated the leading edge. We hoisted it up with the crane. And I just remember someone whispering, now we're going to see, okay, this isn't going to work. I told you so. And the crane lowered the leading edge, perfectly pinned in the tool, and made it up with the front spar. And airplanes have never been designed any other way since then. And think about it now. Could you imagine designing an airplane on something besides a computer? But at that time, it was revolutionary. And you think about AI and some of these other things and how people think about this technology. In 10 years, it's going to be, oh, yeah, I can't live without it. But that experience, to me, helped shape when you're going to do a large-scale deployment, what are the tricks, what are the tools to get buy-in and have people anticipate problems and be part of the solution and not instead of impedance or pushing back and finding all the things that won't work. Well, this is what's really important in these big deployments, is that people can speak the truth. So if you have a concern or you think there's a problem and you put your hand up, somebody says, oh, here's why you shouldn't worry. I know. It's like, when my son works on something and he's like, Dad, how does this work in engineering? I'm like, it's fine. This problem has been solved before. You need to understand how this system all work together. If you create an environment where people can get their questions honestly answered or bring to the attention of management a problem and they'll address it appropriately, these deployments go smoothly. It doesn't mean they're not painful. It doesn't mean you don't find problems, but you find fewer surprises. And that was what was great about that environment.
I mean, you like to get out on the floor and talk to the machinist who's doing the work.
I would always go to the factory.
Mm-hmm.
I mean, everything is about leading from the front. The airplane is the boss. It will tell you if things are okay. So when you go out to the factory or you look at the product, you understand really what's going on. And it wasn't so much that it was me going to the factory to find out how things were going. I was taking the engineering team and introducing them to all the engineers and the manufacturing planners so that they could form a relationship and nothing would ever get to me. They had that bond. And maybe you're different as an engineer, but I've found a lot of engineers introverts.
Yeah.
So we'd go out there, we'd create all these new relationships, and then I couldn't tear them out of the factory.
Yeah.
And then they were fixing things on their own or finding things on their own, and they wanted their offices moved out to the factory, and they didn't want to go to my meetings anymore, and they just wanted to work on, designing airplanes and building more of them.
I'm remembering the first major robotics deployment that we did under my watch at Amazon, which was to take the Kiva robot capability and turn it into a package sortation capability. So put a conveyor top on it, and we built a mezzanine deck with all these spiral chutes and the robots. And you can see these videos. The robots would roll along and kick the package down one of these chutes. And I went to the site. I'd been getting the status reports. I'd been seeing how things were going, and everything seemed green from my team's perspective. And I went and asked the operator, the site GM who was running that, how does he perceive the project to be going? I mean, and in fairness, amazing. His half of his building was under construction because we were building this mezzanine deck, right? And so from my standpoint, I'm like, this is progressing. Like the mezzanine deck's coming in, spiral chutes are coming in. I mean, I empathy for him. He's managing a building in a bunch of chaos. But I'm like, how are you feeling about the team and the technical program? And he's like, I don't feel good at all. And I'm like, I'm getting green status the whole way, and my team's feeling really good. And what I realized was that my team was on site about 3 days every 2 weeks, right? And so for those 3 days, he would feel a little more confident. And then for those 7 days, working days that we weren't there, he just didn't feel like progress was, because for him, the work gets done in the building, right? And if there's no one in the building, nothing's getting done. For us in the software world, like lots are getting done in software and other places to get ready. But it made me realize that, yeah, you have to look at it through the lens of the person who's running that operation. And if engineering's there alongside them, then they have the confidence that if something's going wrong, they can go grab the engineer and say, hey, this doesn't look right. This doesn't feel right. So we pivoted at that point to putting the team on the ground all the time. I mean, everyone wants something that's just turnkey, and yes, that's the objective. But when you're bringing new systems in and new change, you want to know that the team's there that's doing it and supporting it.
If your focus is not on ROI, but on the people, if you demonstrate genuine care and concern, they will reward you with discretionary effort. And you don't have to have all those measurements. You don't have to have all those meetings. They like it because it's making their jobs better. There's so many of these things that were annoying or compliance related that are being solved, and finally they can do the things that they're really good at and they can work. You imagine, the frustration in these operations of having to go find something or fix something or go do something. People working together will solve all the problems, and then that gives, when those problems are surfaced, it's when the engineers do their best work. They fix things.
What I've found is whether it's somebody moving a cart in a transload facility or processing specimens in a specimen processing lab, if you as the operator do the job well, they're motivated by the mission. Leaving the end of the day feeling like you did a good job, the job well done, is an incredibly affirming and rewarding thing. And it's, if the tools and infrastructure, software, hardware, robots help you accomplish that mission.
Well, if you're going to deploy and you look through the lens of the people doing the work, you're going to find a better way. If you're looking through the lens of a spreadsheet or, a union contract or something else, you're not going to get to the right answer. What I've always found is really important. What does good look like? So, all right, we say we're doing a good job. Show me quantitatively that this is the best that can be done. What's the theoretical best that can be done? Now, how do we compare against that? And what could we do with this technology to get us closer to what's really feasible?
I saw a video, and I think this is on YouTube, but of the destructive wing test of the 787. I think a lot of people know this, but maybe you tell for the audience a little bit what was so much different about the 787 and the wings and the way it was constructed, and therefore that test must have been, I don't know if you were there, but it must have been a pretty exciting.
Oh yeah, no. Well, you had to be in a control room to witness it. So there are certain tests that you conduct in the early manufacturing portion of the development program. And so one of the airplanes is instrumented so it can do a static test, a failure test. And the intent of the test is to validate all the engineering models. And so if the wings deflect and there are no structural non-conformances when you get to limit load, which is what the airplane is designed for, then that's one of the bases for getting certification. And the goal then in some cases is, well, how far can it go? How much can we learn? And on the 787, and I'll have to go back and check the numbers, but I think the wing tips were 33 feet above the horizontal. All right, and it didn't break. And you'd end up breaking the wing box before you break the wing. So, I mean, this is an incredible airplane. I don't think you'll fly any place where you see the wings 33 feet above the horizontal. If not, you're probably hanging off the ceiling. So When you think about deployment, there's a component that says, all right, what's the right amount of ambition? What's the schedule? And what's the level of maturity? And when you look at the first generation of commercial composite airplanes, the 787, the A350, and the A220, they've all struggled with profitability because the material system for composites was very robust from a design standpoint, but from a manufacturing standpoint, very expensive. So when you look at the 787, best airplane of the 21st century. It's an incredible airplane. I'm sure you've flown it. It's just like on so many dimensions. But if you are thinking about deployment at scale, to me, kind of rule of thumb is only 3, I'll call them miracles at once, concurrently. So if you were like in a sketch out, and for Boeing at the time, it was, the time constant on an airplane is 40 years in terms of product life.
Right.
So every time you design an airplane, you have a chance to upgrade all your processes, tools, so many things. You only get, there's like this window. So on the 87, they could nail a whole bunch of things. It laid the foundation for the next airplane. So they took on new material system, all electric architecture, new processes and tools, a new supply chain, or just a whole host of these things. Had there been more schedule, there wouldn't have been as much drama, and a bit more time on the manufacturing readiness level would have been a game changer. So as people look at major deployments, there's this huge people component, but there's always how much concurrency of change are you willing to undertake? And that's a management appetite. It's also, what can the organization absorb? In some cases, it may be a real world event where you don't have a choice. But if it's by design, be modest in your ambitions and give yourself plenty of room.
That's something I've certainly learned the hard way as well in robotics, and we bit off something very complicated with the drone program at Amazon. Obviously, with Proxy at Cobot, we really did. We focused on 3 innovations. Every first robotics team out there is using some version of a swerve drive with 4 independent wheels, but an actual production robot with a swerve drive, very rare. For some reason, production robots don't have swappable batteries or self-swapping batteries, so they sit on chargers 30% of the time. We knew we just wanted to solve that problem. From first principles, it didn't seem like it should be that hard, right? You can plug circuits in and out, but it hadn't really been done in a production robot. And then it was really collaborative autonomy. We believed that the technology was there to be able to move through congested hallways. And so, I didn't explicitly think of your kind of rule of 3, but those were the 3 that let's get much more precise mobility. Let's solve swappable batteries, and let's solve collaborative autonomy. And what we didn't do was we didn't go solve the hard manipulation problem, but we simplified that problem. We just focused on grabbing the horizontal handlebar of carts, not because we couldn't come back and add. We designed it so we can come back and add complex, multi-arm manipulators. But by simplifying, we could get out there, get in the field, learn those incredibly hard lessons. AI safety is a big topic these days. What's the role of government? Even the Department of War and Anthropic, discussions back and forth as to, who controls how you can use this technology, what's reasonable use of it. Like, when done well, the aerospace companies and the FAA are both trying to create a trusted commercial airline industry, and the same with the pharmaceuticals and the FDA, trying to create an industry where we trust the medications that we take every day are not going to cause horrific side effects. And yet, inherently with the different roles, there's some level of distrust that emerges in that dynamic. Is it too early to try to bring AI safety and regulation into the AI space, or is it a matter of trying to figure it out together now?
The rules that you design to ensure safety, that's extremely important, right? So that if I follow these guidelines and regulations, I have something that's airworthy. and it's safe. And if I follow these, production regulations, I know I can build safely. The same thing needs to take place in AI. What are the disciplines, the rules, the basis of safety that you evaluate your technology against? And in all fairness to this situation, it's not new. Think about when they developed nuclear weapons early on. Wow, this will destroy the world. Hey, you don't think for a moment those engineers weren't scared to death of what they had accidentally created, right? And we've found a way to manage nuclear weapons. The Vietnam War, they had precision-guided munitions that civilian casualty rate was high, and they figured out how to manage precision-guided weapons. When there were 12 people working on Project Maven, we had no idea about AI ethics and all these other things that would come about. You just don't know. Yes, we need to think about, and sometimes the word safety gets, there's a lot of connotations to safety. I would say product integrity. Mm-hmm. So when I think about AI, I think about product integrity. It works the way it's supposed to. How do we certify it? Now, regulating it is different than understanding how to ensure product integrity. Because companies that are learning as quickly as they are right now in AI are probably best suited to design or define, some of that criteria. The key is trust and transparency, right? So, with Project Maven, I think everybody remembers, so here's this small group of people, Google supporting the project. Then they had 4,000 employees saying, we don't want anything to do with the Department of Defense any longer. There wasn't enough understanding and trust and transparency. So you can, hey, look, I get it. People are concerned. How are these things going to be utilized? The best solution, at least this is my own personal bias, is you have engineers and probably some philosophy majors working on developing that product integrity basis. But you got to be at the table, and you got to be defining those guidelines and then transparently working to that. Regulating is hard. Mm-hmm. So I kind of go back to this. Does this work the way it was intended?
Right.
And as this is going really fast, let's keep the engineers and the philosophy majors helping to define that and make sure that that's being driven back into the companies so they can deploy it and make it better. You bring in too many other parties, and then maybe the bias shifts towards, different stakeholders. But engineers and people who are really sound in logic, we need them at the table, whether it's working with the Department of War, with, the medical companies. Here's how we safeguard these tools and go more quickly.
You oversaw the Department of Defense, which is 3 million employees, the largest employer in certainly the United States, if not maybe the world. When you think about team and you think about creating, hiring, attracting, building, how do you think about it? Is it about hiring? Is it about attracting? Is it about developing? Is it all of the above? Like what goes into team for you?
Well, most of the teams that I've led, I've inherited. So a lot of it is motivating the teammates that you have. And I would say to get there, some people don't make the journey. In my, logic and the way I think, people opt out. Okay? I've never fired anybody. People fire themselves. Or people decide that they don't want to come along on the mission. People have a good track record. Other people with a good track record, they all like to work together because they know their time isn't going to be wasted and you can make real progress. Or they have a loyalty and they want to go do something that's really important. In general, in very large organizations, leadership casts a long shadow. And if you have good leadership, you're going to get good performance. It's always nice if you could start from scratch and build exactly what you want. That's just not the way life works. And there are remarkable people everywhere, and they'll always surprise you. And nothing fits into a magic, in a formula. But if you, again, back to genuine care and concern, they're going to reward you with discretionary effort. You have to protect them. Mm-hmm. You have to look out for them. Mm-hmm. and you have to be available, and it just, I mean, there's no secret sauce other than you have to be visible, fix real problems. I guess maybe a big difference is you can't be a manager where you're just grading other people's homework, that you're the first one when there's a problem to help, to bring resources.
I mean, it seems like motivation is both at the macro, the mission, right, and at the individual, is what you're saying.
No, we're in the people business.
Yeah. Yeah.
Look, people want to do a good job.
Yeah.
A friend who worked in the automotive industry, and he said, I think this applies in general, management gets the union it deserves.
Right.
I've never been disappointed. Every place I've worked, great people.
Yeah.
Yeah. So.
Yeah.
In the Department of Defense, that was probably like the highlight of my life, working with the men and women who put on the uniform, the civil servants, and their quiet professionalism. We owe them incredible respect and appreciation. They are the backbone of democracy. And you talked about it, the Department of War, 3.3 million people. A lot of people just don't understand how big or how government really works, and it's easy to be critical, right? So in a big company, I worked in a big company. Boeing had 150,000. I had a little over 40,000, which you think is a lot of people. You had a board of directors that was 10 people. They met, 5, 6, 7 times a year. They'd make a decision. They'd give you resources. CFO would slap the table. You could go do your job. Department of Defense, there are 535 members of Congress that serve as the board of directors that go to work every single day. They are continuously doing their job, managing the department. So there's a level of complexity I don't think people understand.
Right.
In the Department of Defense, 15 layers of management.
Mm-hmm.
Okay, so it's not as though you can kind of reach out, just touch everything. They operate in 178 countries. And the biggest difference between running a business and working there is in the Department of War, it's continuous operations that are unpredictable. If you run in a business, now look, manufacturing and engineering, it's just chaos, right? It's chaos.
Right.
It's very programmatic. It's deterministic. So imagine deployment in the Department of War. Also, just think of the amount of money that goes through there. When I was there, I was responsible for the budget, and we were spending $2 billion a day. With the $1.5 trillion budget being proposed, that's like $6 billion a day. So it's a remarkable place. When I went to work there in 2017 for Secretary Mattis, we were very focused about modernizing the military.
Mm-hmm. Mm-hmm.
Kind of go back to, how do you think about innovation and deployment? And what's a little bit different there as a political appointee is you have about 1,000 days. That's it. And our mindset was every single day matters.
Mm-hmm.
So we put together the National Defense Strategy, and it wasn't a 500-page document. It was a very small document, and it was very specific about where we were going to concentrate on innovation: cyber, space, AI, precision strike. But our focus was narrow down the innovations, and then we put the budget together, apply the money, grade everybody's budget submittal against whether you were funding those technologies. And so when you think about it, those 12 people in Maven, it's grown into being something remarkable. I had someone come to my office back in 2017 and said, by 2026, which is where we are today, there will be persistent surveillance of the globe. And I was like, oh my God, that's unbelievable. We need to figure out how all of that works. And we can talk about the Space Force, but the Space Force was really stood up to address the procurement of commercial space technology
Mm.
and leverage it into the military,
Mm-hmm.
right? So there were like these 3 or 4 things we said we need to move out. And in that kind of environment where I was just describing, it's unpredictable, everything, the mindset was every day matters. Batting 400 gets you in the Hall of Fame. So you're going to make mistakes. There's a whole bunch of things when I look back, it's like, oh, that was like on the Jedi cloud contract. Maybe we should have done a different procurement model. But there was no cloud, and everybody was developing their own cloud. There wasn't AI. And what we knew was that when there was a proliferation of low Earth orbit satellites, we were going to have to ingest all of that. And if we had this distributed architecture for cloud, we couldn't get the benefit of infinite compute power. And if we didn't have common models that we had developed and trained at a department level, how could you trust some of these models? And it was just the start. You just got to start. And you're going to make some mistakes. And you're going to take some sharp elbows. And that's just life in the real world.
Now, you've worked on, I mean, some of the most advanced, aerial capabilities that anyone's ever developed. The B-2, the F-35, the airborne laser. What we're seeing now is a proliferation of lower cost drones, right? As the kind of tip of the spear in war fronts like Ukraine.
So it's all about creating a credible deterrence against the right threat. So in some cases it might be attritable autonomous, vehicles. In other cases, it, maybe other effects. I think software is easy, hardware is hard. The phenomenology of directed energy weapons is so much different than training an AI model.
Mm-hmm. Mm-hmm.
Dealing with atmospheric compensation and all the things that go along with mixing chemicals in the back of a 747 and generating all that, energy. I mean, there were people with 150-pound brains working on those projects. AI is moving into the physical space. What's been great to see at the Department of War is all the commercial technology that's found its way into modernizing a lot of the systems that keep people from just leveraging the great technology they already had.
Right.
Small companies can move 1,000 times faster than the big companies. The big companies need to figure out how to partner with the small companies.
Mm-hmm. Mm-hmm.
But there hasn't always been that appreciation, and there's always this verticality. Well, I can do it myself. You really can't. What does that deployment roadmap really look like so that you can go from 12 people working on Project Maven to, Epic Fury?
I think the advantage startups have, as I've worked in both scales, is that it's easier to make those type of leaps. So early on at Cobot, we were designing subsystem hardware test platform, right? We were testing the mobility platform. We were testing the sensing platform. We had a robot called Sensei, and we had a robot called Pavlova, and we were like build. And at a certain point, we had a customer that was expecting a robot, and we were looking at the timelines of how long it was taking us to build these subsystem tests, integrate them, try to make it work, and we're like, this doesn't converge. The schedule doesn't line up. Talked to the engineering team. Lead mechanical engineer was like, I think we need to stop building. Mechanical engineers love to build things, right? Like, we need to stop building. So I remember this vividly. In March of 2023, we stopped building anything, and we just went into the tools, and we decided to design the whole robot digitally. And the first parts didn't start coming until September 30th that year. So there was a 6-month period where, as CEO, there's no robot. There's nothing. We were joking that
raising money,
money, selling to customers. We're like, here's our robot, right?
Here's our PowerPoint robot.
By November 14th, we had a fully functional robot, version 1, completely running. We had a board meeting on November 14th, and we said, by the board meeting, we're going to have this up and running, and we did. But I think, to your point, that's where startups play such a key piece in this ecosystem, is that we can take those leaps. I mean, it's impressive that Boeing made that decision and made that bet, right? And obviously Microsoft, famous for doing that with the internet, right? And sometimes you just need that, like, kind of whether it's the board or the founder, you need that kind of clarity of like, we have no choice. But startups bring that energy every day because we're constrained and we just have to decide which leaps we're going to bet on to make sure we can get there. But so many companies, it's so hard to make those bets.
What excites me right now is a handful of people can make a huge impact on large industrial companies. I don't think people really appreciate it. I mean,
the leverage these tools give us.
Well, I've seen what people are doing with the development of AI and how quickly it's moving. And then I've worked in those spaces where there is a direct application that you could put in place tonight to solve so many problems. And I don't think people really understand how this technology works. There's a huge mismatch in understanding. It's almost as if there should be, boot camp for a lot of these. Think about these very senior people. They have optimized their companies for growth, profitability, all these things that they're doing. They barely have any bandwidth. And think about how dynamic the world is. They have no bandwidth. And there's this miracle drug that's available. And that's the opportunity today, is to marry that up. So how do you give them the bandwidth so that it's easy to say yes? They just don't know.
Right.
And you just walk around, you can say, that could be fixed. Not just fixed long term. How about next week? Some of these things, it's that straightforward. And then there's the bigger workflows that can be optimized that just crush lead times, crush managing these supply chains. And we're just on the doorstep, and hope to play more in that space. It's these are exciting times.
Look, you've worked on a lot of very complicated systems, right? And yet there's a renewed resurgence in like deep tech, and we have startups doing supersonic jets, air taxis. What advice do you give to VCs? What do you encourage them to look for when deciding to make an early investment in a big bet?
Since leaving corporate America and obviously finishing the restructure at Spirit, I've developed a much deeper appreciation of the role of VCs. The insight I've had is the really unique ones form incredible bonds with founders. And when I think about the transformational effect in these large industrials, and back to the comment on there's not a significant number of people that can have a huge impact, creating that same kind of relationship with the people that are leading in these organizations. They don't have the bandwidth. You know how they give great advice to founders? Here's what you're going to experience.
Right.
Let me help you out on this. I can make this phone call. Well, the people of these big companies, it's like Kodak. They had 80% of the film market and invented the digital camera. They know there's an application here. They need someone to help them, the trusted relationship or a partnership where they can make the bet and they're not putting the business at significant risk or their career at significant risk. And I say this kind of tongue-in-cheek, the consultants that are going to be displaced by Claude, they should probably hire a few of them to help them with this change management, which is, here's the arc of the technology and the progression and the roadmap and how it manifests itself in better company performance. Here's how you want to instrument your organization and have your management give you feedback on how things are going, and then create a conduit for honest communication.
Mm-hmm.
In this deployment with our founder and the things that we're doing here, this is what's not happening. Your team is blowing them off, or it's not getting enough resource, or my guys aren't. I think these VC partners, leaders, creating that relationship will have a transformative effect in really making these technologies more successful.
You're always framing things through that empathy lens, whether it's that individual or that machinist or that person who, you inherited the team and so they're now working for you, or the operators in that brownfield facility, or the folks, waking up every day with a mission to defend America. Like you approach all of these problems from an empathy. Let me understand them. If I understand them, then I can maybe fix the system or the change, because it, as you said, it's all a people problem. And there was a day where we had a tough day in the deployment, right? And you just said, look, I'll be like you could tell that you'd put yourself in my shoes, like Brad's having a tough day, right? And let me go to the site with him, even if I don't go in with him. He's got to go have a tough conversation. Like, as impressive as all the technical accomplishments are and the kind of systems you've brought to the world, it's that like leading with empathy in all of those problem solving that's really inspired me. Awesome. This conversation was so energizing for me and so enjoyable. And I think the world is very dynamic. We're going to see where AI takes us, but your point about the leverage that we're going to have to build in the future that's what gets me excited. Not just AI, robotics, the idea that you can envision something and it's going to be that much faster to realize it is what gets me excited.
You're one of the kindest people I've met. You are a kind person, and I would, hands down, tell anybody you'd be lucky if you could work for Brad. So you are a remarkable leader in that way. You're just wicked smart. I love engineering, but I'm more like MacGyver. You're the 150-pound brain. Yeah, you solve the big problems. You not just understand them. You're a builder, and there are very few people that are builders. And that's why I know this company is going to be wildly successful. And you'll probably have a few more bad days, so keep me on speed dial. And but I think there'll be a lot more good days than there are bad days. And you're just doing an incredible job, and I appreciate the opportunity to spend some more time with you.
Well, thank you.
Welcome.
Thank you so much, Pat.
Invite me back next time, and I'll interview you.
Awesome.
Okay.
All right.
Thank you.
Very good.
All right.